Okay, continuation of the topology. The first really weird one is the Klein bottle, which in a sense is exactly a combination of the properties of the Möbius strip and the torus. And the unfortunate thing is the extrinsic picture doesn't work well in 3 dimensions. We had to have this shape that passed through itself. Well, if I am allowed 4 dimensions, then that's fine. For example, if I think of, I just need another number. Remember, 4 dimensions doesn't have to be another spatial dimension. It could be time, it could be color. I could just color all the points on a surface, different colors. Anything that has sort of, you can interpret as a number can be a 4th dimension, because we know that that just means 4 numbers to play with. So for example, if I just colored most of the bottle blue, but when it sort of pierces through itself, I color it red. Well, that means that in 4 dimensions, those aren't the same point in 4-dimensional space. Yeah, they have the same x, y, z coordinates, but they don't have the same color coordinate. And so that gives you a hint as to how in 4 dimensions, the Klein bottle is actually perfectly nice. And it's basically almost as nice as the torus. It still has some of these weird features in the Möbius strip, but you can still draw a very nice picture of it. Now, there's one case, though, that I haven't talked about. Actually, there's 2 cases I haven't talked about. What if so here was the torus, right? What if I flip both of them? What if I glue the top and the bottom of the flip and the left and right of the flip? So let's glue the left and right of the flip first. That's the Möbius strip. Okay, so we've got this Möbius strip. And then what I want to do is somehow glue this guy to this guy. Well, let's see. Now these are actually now part of the same one single edge. But what it means is that if I look at a point here, let's say, then I look halfway along the edge, just go halfway along the edge, okay, and on the opposite side, I want to glue those points together. And the thing is, I want to do that for all of the edge. It doesn't take long fiddling with that in your hands to figure out, let's see, I want to seam that together, and that it's not going to work, again, in 3-dimensional space. It doesn't sync up nicely in 3-dimensional space. Another way to say it is that because everything's stretchy in topology, we can, instead of gluing the actual existing edges, which might be hard, which is definitely hard to picture, what we can think of as taking an extra circular piece of fabric, a disc worth of fabric, and that's got a circle for a boundary. Well, this one edge, even though we kind of looks like it should be 2 circles, is really just one big circle. And what we can do is, if we want to get that edge out of here, which is the purpose of gluing these 2 guys together, if we want to get that edge out of here and have a surface with no edges, it's closed up, I can just glue my disc, I can sew my disc onto here. So I just start sewing, and I start sewing part of that circle onto here. What you discover when you do that, if you actually try to do it, is that disc gets bunched up, and it wants to intersect itself. It wants to pass through itself. So it's not too surprising. Since the Klein bottle had to intersect itself, and it only had one twist, it's not too surprising that this weird surface has got to intersect itself. Well, so let's go back to the intrinsic version of things. What's going to be true there? Well, what's going to be true is that when I go in any direction and go in a circle, I'm going to get the flip phenomenon. So one thing I forgot to say about the Möbius strip and the Klein bottle is, for example, if I take the letter R and I just drag that to the right, it's going to come back. Let me drag a little bit downward so it doesn't interrupt itself. It's going to come back as an upside down R. Let's see if I can draw an upside down R. Yeah, okay. And you might think, oh, okay, that just got rotated. Well, no, that's not rotated. If you look at it upside down, that is mirror reflected. And so I come back, the thing comes back as a mirror reflection of itself. That's weird. If this was like the universe, if this was like a model for our physical space, you'd come back, if you start out right-handed, you come back left-handed. That's very, very strange. And there's a good video about that I'll show you guys at some point probably. And then it's just going to continue being that upside down R until it goes to flip again, and it'll come back as the usual version. So that's kind of weird. If you drag an object and try not to change it as hard as you possibly can, when you come back to where you started, it has changed. It has changed its orientation. It's a lot like the signed area stuff we're doing with the determinants right now. So that was true about the Möbius strip and the Klein bundle, because they had one flip. Well, but in the Möbius strip, you couldn't go from this top to the bottom. They weren't glued. And in the Klein bundle, there was no flip there. But in this new case, I haven't named it yet, but in this new case, if you go up on the top, you come back as the flipped R. So anytime you go around one of these two directions, you flip. It's basically anytime you go anywhere in some straight line and go around the loop and kind of come back to yourself, you're going to end up with a flip of orientation. So that's definitely weird. Let's check the time. Okay. So we've got some inkling that this is a weird surface, that it probably doesn't sit well in 3 dimensions. It does sit very well in 4 dimensions, by the way, just like the Klein bottle does. But what should we call it? Well, it turns out that this is actually a rather old object that people started discovering from geometry. And here's the idea. I take the plane, the whole board, and I observe that there's this kind of annoying thing about basic geometry. Oh, and I'm going to have to cut this off because this room's going to get used. Yeah, let me cut it off and continue this. I'll go with a punchline. What I'm going to explain is why this is called the projective.